Okay, everybody, I'll get started on this again. All right. Well, we're gonna keep going with this and see how far we get. Tonight, we're gonna go cover some material that I think is it's gonna represent what I learned on my own doing this coding offline. If you remember, we are coding a version of Wordle, and we're now at the part where we have to figure out how to update the row with our guess. We now have to figure out how to update the squares so that they have the right encoding for whether it's in the word, for whether it's in the word, or whether it's in the word and in the right place, or whether it's not in the word. And again, we have a loop here, the game loop, where we're going to try to calculate the guess row appearance, and that's where we're at. And I came up with this original initial algorithm, but I think it might be easier to go over this if we just start with the test. We'll go get this going, and now we have some guess row tests here, but oh, did I not do this? Oh yeah, I did do this. This'll get fixed in a second. I'm getting used to the Xcode doing its thing while I'm working. You can see here it hasn't caught up yet, so yeah. What I'm going to do is show what the test would look like, and I'm going to do this. I'll call it test. Let's say test update row. And we're going to pick a test case here, maybe Craze. And this is a convention. You'll see what this is in a second. When the user comes in, they're going to enter in a word, say crabs. That's their guess. What we're going to do is we're going to have the guess update correct word of craze. So this function, it doesn't exist yet, will, when we print out this row again, it's going to look like CRABS. CRABS. And I was thinking, if this was I was thinking I could make a utility program to make these rows. Maybe a utility that would say something like I don't know, like make row, and it would be plus C plus A plus R plus A BS, and if was in the word, we could make it be minus S, for example, and then this could print out the I have it here. I was thinking about making utility. Maybe when I finish writing this thing, I'll make utilities. But right, so there's no this is what the test will do. We're going to try to run this test now. Actually, the test has already run here. If I run this test, it'll complain with an error. It'll complain in build time because the thing doesn't exist yet. So what we have to do is go and make this function. Update row is really this algorithm. So we're going to test this out. We're going to try to implement this, and during the implementation we're going to explore a couple of Swift ideas and Swift concepts that are, I think, well, that were definitely confusing to me when I was fooling around with this. So let me see first if I click on here, in other IDEs that I work in, usually there's something that says, hey, you want to fix this? And I thought that maybe, I could get like even some help here, but apparently not. So I'm going to go to GuessRow, and I'm going to make a function called UpdateRow. That's what I called it, right? Yeah, UpdateRow. And it's going to not return anything. And when I save this error should go away because now there is a function. But I have to give it an argument. This may fail. Let's see if it catches up, because the source code is specifying an argument. Yeah, argument passed to a call that takes no argument. So we're going to make this take an argument. We're going to make this take a correct word argument. That's what we're going to make it. And that will be, nope, not that. That'll be correct word. And it's going to be a string. Now, remember in Swift, this is the argument label and this is the parameter. So, right. Now, there are no build issues, but if I were to run this test, build failed. Not necessarily. Let's run this test and see what we get. And close these, make it easier to focus on just this. And build succeeded, but now let's see if it passes the test. I thought I had solved these problems with the speed we may end up going back into the editor. Oh, here we go, it's running it now. Yeah, and so the assertion failed. We can go in here and we can see that what was returned was just the row. We need to update these. And this is programming right here, because clearly what we need to do in here is update this array such that it will represent this new state, where if the correct word was craze, C-R-A-Z-E, if we enter in a guess row with a guess of crabs, only the first three would have the green square. Only the first three would have pluses. So that's where the algorithm comes in. And I hope if you're this, but this algorithm is a two-loop algorithm. It loops across all the guesses to see if any of the letters are in the correct position, which is in fact what this first issue is. If any of the letters are in the first position, then we mark that guess as inward true and incorrect spot equal true. And then we remove the matching correct letter from the array of correct letters. Now, we're going to learn some things about this, but this is the first loop. It's going to figure out correct letters. And I'm just going to quickly just want to do a okay, I started that twice. I have some notes here. Nope. Right. We got to understand String.Index, and we have to understand loops, and we can't remove words in the first loop. So I have a little outline of some of the things that we need to cover in order to understand how to complete everything, but we won't need to go over it in necessarily this order, although maybe this first one we can do in tonight. Let's just start coding this. You coming up with this algorithm. Let's briefly talk about this. This is, I think, the heart of being a programmer. You have to understand how to go from A to B. You just have to. And I'm programming in a very, what I call, simple style. The way all computers understand things. I'm programming imperatively. I'm telling the computer, start at this and compare with this. That's all that we're doing. But this is the heart of programming, and to some extent, I think if you like to solve puzzles, or if you're maybe good at math problems, you might start to get a feel for what it would take to come up with these algorithms. And I'm not even saying this is a good algorithm. I'm just saying wrote by purely mechanical means, this is how we can go from crabs to craze, crabs to this. And wasn't sure where I'm trying to say that this part will be incredibly difficult to try to teach. I'm trying to remember even how we were taught these in school, but then I just realized how we were taught this was just to solve these problems. Just take something and solve it. You can't, maybe don't start with something difficult, like, oh, I want to implement Minecraft. Well, that would be, it might be hard if maybe you didn't understand how to represent 3D. Start with something very small, like this guessing game that we did. I just want to remind everybody that we have a small guessing program. Guess my number. It's between 0 to 50, 0 and 100. I'm going to say 50. I'm going to say not even close. I'm going to say 25. Oh, I'm warm. Okay, so I'm going to say 28. Oh boy, guess again. Warmer. 29. Really warm. 30. This game right here, if this is confusing, and I had a whole, I think 6 or 7 episodes, maybe it was more like 3 to 4 episodes. We came up with how to write this game. You can imagine there's a simple loop. You can imagine there's an if statement. And you just build from that. And again, I'm just trying to express that learning how to problem solve, how to express instructions to a computer is greatly difficult, but something that you can learn by just starting to solve these little problems. And is you could just go to Leetcode. This is something that, okay, I only did exactly 2 of these exercises, but if you go through the problems that are here, let me sign in. I'll show you what I mean. Been a long time since I've been on this site. I like this feature with the notebook. I'm doing this problem, I think it was add 2 numbers. Yeah, and here I have some failures. Last I worked on this was last year. The problem, and again, we're not going to do this, but this is an incredibly long digression. What's happening here is that you're given a, let's see, yeah, you're given a linked list, and you need to sum these things up. And this is what you have to start with in C++. I did these all in Python. So I wonder, do they have Swift here? Oh my goodness. Maybe I'll be, now I'm vaguely enticed to come back to this, but these are the kinds of problems that hopefully are interesting to at least stare at and work through for an hour or two. And I did go to school for computers, and this is a lot of what we did in school, was just solve these problems, and they got increasingly difficult as the years wore on, and to the point where coming up with a little algorithm to implement this is relatively straightforward, even though I couldn't tell you whether this was a great algorithm. There's certainly certain measurements of it. I mean, the fact that it takes 2 loops, I'm still thinking about that one. But all right, well, enough talking. Let's just go through this first part, and then we can call it quits, because let's in fact make it easy on ourselves and just grab this text and put it right into Xcode. Let's see, pop it right in here, right in there. I don't know if it's gonna. Yeah, I think I can even do this. Oh wow, Vim mode? Hang on. Okay, let's come back to that. That's the first time I've noticed that, and that's exciting. Hold on though. I thought maybe I could quickly make these into comments. Okay, I guess not, but in some editors that I work on, I can press Control and / and it'll put comments here, but let's go into Vim mode. This is incredible. Holy mackerel. People, this wow. Vim mode. I'm just, oh my goodness. Look at that. There's a little little cheat sheet down here. Visual mode B W E. This is, you know, that's incredible. I'm just gonna put these it doesn't have period, which will repeat the previous command, but I mean, this is pretty good. This is pretty good. Wow, I'm just amazed. Okay, all right. So, okay, let's come back. We're in an object, the guess row. It contains the letters of the guess, and what we can do is loop through every letter in the guess and ask, is the guess letter in the same position? Is the guess letter in the same position as the correct letter? And so the first thing we'll do is we'll add a loop here. We'll say, basically we'll do something like this. For C and guess letters, we're just going to say if C dot char is equal to, now here's something interesting. What we have to do is get at the correct the guess. So we want to do something like this, s dot I, for example. Now, at no point did I set up I, so I'm going to do this. Let I, not let. I think I need a var variable. This is going to change radically. This is a loop counter. We want to do something like this. If this is the case, then we're going to do C dot inward is true. And we're going to want to get the word and get the letter and remove it. We also want to mutate this I, so we do something like this. Maybe I don't think you can do it that way in Swift. Okay. So right away we're running into this problem here. You can't subscript using this underscore technique. I mean, using the subscript technique. And believe me, this is something that this is incredibly maddening to me. When we're 25 minutes into this stream, and but you see what this is doing, and I also want to do this. If I were to get this right, remove the matching letter. S dot remove letter. Now, let's handle this business here, the subscript. When we make a string, I'll just go right to my notes. When we make a string, we can do this all in the REPL. Well, we can when we make a string, we can index it using this thing. First of all, we can't index it. Let me be. We'll just go and put this in there. So we have a string now. What we want to do is we want to say, I should have made it like, let's do string 2. I'll put here the thing that we're examining. Correct word is craze. So I'm going to say, okay, what we want to do is we want to say, what is the first character in this string? And in many languages, I can do this. String 2 0, and I mean, let's just do this here. Fire up Python, and we're going to do the same exact thing here. We're going to say str2 equal craze. Look at that. That's in Python, and that was purely from memory. I was expecting a syntax error, but I'm really happy. And I think in Python you can even do this. Maybe it's this. Maybe it's this. Maybe it's this. Yeah. You can see that there's string indexing available using the subscript operator, and this is in Python, but not in Swift. Why is that? Now, we can go all the way to the we can go to the standard library documentation, and actually, yes, with language guide, and we just have to learn about strings and the reason why we can't do a subscript is because the strings inside of Swift are Unicode compliant. And what does that mean? Scroll up here. Go right to the exciting example. Here's a string, and it's got the dog head emoji. That's expressed as a UTF character, but string understands that as a single character, and basically the string inside of Swift is aware of UTF-8, which is character encoding that allows for a wide range of emoji and also different languages, different character sets. I'm not here to say I'm an expert in UTF-8. It was very difficult when I started to encounter it as a professional, looking at things the old ways. But when you read this, and I'm encouraging you to read this, I'll put this into our chat. When you read this, it explains why the subscript at least is difficult to implement when you have UTF-8 strings. You can't do it this way. I found that what you can do is use String.Index in this fashion. So if I copy this, I can then do something like str2. Let me just see what the thing is. Yeah. And this will grab character number 1, which is R. See that? See that? That's and this is String.Index, String.Index with encodedOffset 1. It turns out if you add this in here, let's add this in. Make a variable here. This Vim mode, people. You can use VI in Xcode out of the box. I didn't have to install any modules. This is kind of blowing me away, really. It's blowing me away. So here I am. We're using IDX2. Let's even make it a let. I mean, look at this though. We get this crazy thing. We get this message that says that the encoded offset has been deprecated as most common usage is incorrect. Use instead this guy to achieve the same behavior. There's even a fix here, but I'm not going to click on that. So there, Xcode will offer to fix things, but I guess it has to be very simple. But let's concentrate on this warning. It's saying instead to use something like this. String.Index UTF-16 offset in. And so I put this into Swift forums. I bookmarked this. And I'm going to put this into the chat. And I think we'll end with this. We'll end on a cliffhanger. This is a post from January 2019, and here we have this person, Michael, expressing some ideas for how to improve on the indexing, String.Index, and more importantly, the fact that encoded offset is soon going to go away. We want to replace it perhaps with something else. And here he talks about original proposals. Here he talks about what it means, what things need to be designed further, on and on. I'm not saying I read this whole thing. I am saying that I bookmarked it because it talked about why you would want to use the newer mechanism. And it is It's deep, it's complicated. In the end, the compiler, Swift, is telling us what to do to fix this. It says, don't use this. Instead use, oh, not that. Instead use, oh wow, it's gone now, the warning. It's basically saying use this. I'm going to say IDX1, String.Index UT, and the variable in. What's the variable in? Well, it's the string that we're indexing, which is the correct word, S. We're going to replace this with IDX1. And I'm not saying, let's see if the build succeeds. And yeah, it kind of does succeed. And I want to run this test because now we have this thing working. So let's run it. Okay, here we go. Let's see what happens. Oh, failed. What's its problem? Ooh, look at that. We did almost get it working. Oh, I didn't do this. The offset has to change. It has to change by the loop. So let's change that. Run the test again. Yeah, we're almost at 40 minutes, so I think we will stop here. Let's see if we can get a successfully running test, and it worked. It worked. So the next part of this algorithm is to, when we find a letter that is in the correct spot, we then remove it from the string. Let me go and commit this. We're going to do this slowly. Okay. You see, I already have the tests in there. So, yeah, there you go. Tomorrow we'll complete just this first part, which is do nothing, and I'll also introduce you to a simpler syntax, so that we have this variable here. There's probably other ways to express this, and we'll get into that tomorrow. We'll just catch up with everybody then.